Hi there, welcome to another video on geometry, and today we're going to continue to calculate angles and now look at a special case, vertically opposite angles. When two lines intersect, and remember that intersect means cross, they make four angles, which I have labelled over here. The opposite angles are the same size and they're called vertically opposite angles. So you'll see how the blue angles 1 and 3, they look to be about the same size. They're both acute angles, and it actually will turn out that they will be the same size. So they're going to be called vertically opposite to each other. And the same thing is true for the green angles, angle 2 and angle 4. They're both obtuse angles, and they'll turn out to be the same size as well. So let's examine why that is. If we look at our first system here, our system of lines, we'll find a straight line. So there's a straight line there. And if we ignore what's beneath the line for now, so let's ignore this, we'll remember that to find the angle B, we'll go 180 minus 55 will give us B. And that's going to be 125. So this angle B is 125. If we get our ruler, and now instead of looking at the straight line along the base there, let's look at the straight line along here. Well, on the left hand side of the line, so over on this side, we can see that 55 and 125 equals 180. And if we examine the other side of that straight line, we'll see 125 plus C must be 180. So we'll go 180 minus 125, and that gives us 55. So this angle here must be 55. And then examining the system as a whole, we'll see that the opposite angles in the system are equal. So the vertically opposite angles, they make kind of an X, and then you look for the angle that's through the other side of the X from it. And you're going to have two acute angles and two obtuse angles, unless they're all 90 degrees. So you can pair them up, your two obtuse and your two acute, and they'll be equal to each other. Let's look at another system. Here's one. So now that we've just learnt about vertically opposite angles, straight away I can fill in that this angle B is going to be 35 degrees because it's opposite the other 35 degrees. So those angles are the same. And to find angle A and C, well, we do what we've been doing before to calculate, where we get our straight line and we know that 35 plus A has to equal 180. So we go 180 minus 35 equals 145. So A must be 145 degrees. If A is 145 degrees, C is also going to be 145 degrees because they are vertically opposite. And you can even write that in. If you were writing down your angles, you could say C equals 145 because it is vertically opposite. One more system. Here we go. Okay. Let's fill in the information we know. We know this 30 degrees and we know that this symbol up here stands for 90. But we don't know any other values. Well, let's look for the straight lines, what we've been doing all along. Here's a straight line, and we know there's 180 degrees in a straight line. If there's 90 degrees up on the top right, that means that B must also be 90 degrees. We can draw a straight line vertically, coming down, and do a similar process to find A. Or we could also say that A is vertically opposite to B. So A is also going to be 90 degrees. And then we know in a full rotation, about a point, the full thing is going to add up to 360 degrees. So all of this will have to add to 360. So we can say 360, take away 90, take away 90, take away 90, take away 30, will leave us with 60 degrees. So this angle D must be 60 degrees. And filling in the angles that we've just solved for onto the diagram is a very useful way of leading to other angles. So I would advise drawing out the system and filling them in, every piece of information you know. That was vertically opposite angles. Hope you found it useful.